We're going to start off the year by looking at some special cases for factoring. Some of these you've seen in Algebra Trig, and some of them will probably be new to you. I'll cover 3 different ones in this video, and then we will practice them all in class. So the first one is composite expressions. So composite expressions, what you're looking for is a function inside another function. So you're looking for algebraic expressions inside parentheses. And here's an example. We have 5a plus 1 quantity squared, and then the 5a plus 1 shows up again with a coefficient of 2 in front of it. So if you look at this, this is really a trinomial. I have three components to it. And what we have to do is you have to be able to recognize the form where you see the same expression in the parentheses. And what you'll do is replace that expression with an x. So I'm going to let x be equal to that whole quantity 5a plus 1. And then it's going to look a lot more familiar to you. So I'm going to work through this problem now. We said we're going to let x be equal to 5a plus 1. Now my expression looks like this, x squared minus 2x minus 3. And that's pretty basic. We just factor the trinomial, and a 1, and a minus, and a plus. Notice we're not solving it. There's no equal sign. We're just going to factor. But at this step, remember to substitute. Substitute the original expression back in. So instead of an x, I got to replace that with the 5a plus 1. So that ends up being 5a plus 1 minus 3, 5a plus 1 plus 1. So my final answer is 5a minus 2 and 5a plus 2. So we'll do one more example like this. Here we have x plus 3 quantity squared minus 25. You could multiply that out and simplify it and then factor it, but since x plus 3 is an algebraic expression, I can let y be equal to that, and then I have y squared minus 25, which factors into a difference of squares. At the end, don't forget you have to substitute. Instead of the y, you have to replace it with the x plus 3. So it's x plus 3 plus 5, x plus 3 minus 5. And that ends up being x plus 8 and x minus 2. So that's factoring when you have a composite. You just use a let statement and make it a little bit simpler and turn it into something that's more familiar to you. The next type of factoring I believe you did in Algebra Trig. It's called factor by grouping. And we use this when we have 4-term polynomials. And it doesn't work all the time, but there is a way to check. If you have your 4 terms in standard form, then the product of the 2 inside numbers should be equal to the product of the 2 outside. The 2 inside terms equal to the product of the 2 outside terms. So that's the way you can check to see if factor by grouping is going to work. So here we have our example. We have our 4 terms, and it's in standard form. So I'm going to check by checking x squared times 4x. X squared times 4x is 4x cubed, and then x cubed times 4 is also 4x cubed. Since they are the same, it's going to work. So here's what we do. We have to group the first 2 terms and group the last 2 terms. First 2 terms, we group the last 2 terms. So we use parentheses to group them. I have x cubed plus x squared, and then this plus sign stays there, and then I have 4x plus 4. What's going to happen is you're going to be able to factor a GCF out of each one of those binomials. It's going to be a different one in each case, probably. So when you do that, between an x cubed and an x squared, I can factor out an x squared, and I'm left with x plus 1. Over here, between a 4x and a 4, I can factor a 4 out, and again I have an x plus 1. So here's what you have. You should end up with a coefficient and a binomial, a coefficient and a binomial, and the binomials should be identical because you're going to factor that out as a GCF again. Factor the binomial as a GCF. So we're going to rearrange this again. My binomial is x plus 1. When I factor that out, I'm left with x squared plus 4 as my other term. Now I cannot factor x squared plus 4 anymore, so this is factored completely, and that's how you factor by grouping. You group the terms, you factor a GCF, you factor the binomial as a GCF, and that regroups the terms into two products, or a product of two terms. So you have to be careful with factor by grouping when you have subtraction between the two middle terms. We want to make sure that's going to be a plus negative. So let's first check. Negative 2x squared times negative 3x is going to be positive 6x cubed. X cubed times 6 is positive 6x cubed, so that's going to work. Here's what I'm going to do. X cubed minus 2x squared. Instead of that subtraction, I'm going to insert my addition symbol and make that negative 3x plus 6. I did not change the meaning of the expression. I just changed subtraction to an addition. Because now what I can do is I can place my parentheses in here. And if you don't do that, you're going to end up with the wrong sign in one of these terms. So between an x cubed and a negative 2x squared, I can factor out an x squared. X squared times x minus 2 plus, over here, between a negative 3 and a 6, I'm going to factor out a negative 3. Negative 3, because what happens is that turns the positive 6 into a negative 2. Not a negative 6, a negative 2. If you do this correctly, your binomial terms should be identical. So then you factor that binomial term out, and you're left with x squared minus 3. We'll leave it at that. I know x squared minus 3 could go into plus or minus radical 3, but we're going to leave it with some whole numbers here. And that is factor by grouping. The last bit of factoring we're going to do, I believe, is brand new to you, but it will be helpful next year when you start reducing fractions down that have perfect cubes in them. So this is factoring a sum or difference of cubes. Perfect cubes are numbers you get when you cube a whole number. So perfect cubes are 1, 8, 27, 64, 125. If you take the cube root of those numbers, you will get a whole number. As far as variables, any exponent that is divisible by 3 is considered a perfect cube. So those are the terms we're going to look for when we do this process. To factor a difference of cubes, I would have a perfect cube and a perfect cube with subtraction in between. And there's a pattern to this that you're just going to have to memorize. All difference of cubes break up and factor into a binomial and a trinomial all the time. So the binomial is going to be the cube root of the first term, which will be a, the same sign, and the cube root of the second term. Then what you do is you're going to use these terms to get your trinomial. The first one is going to be the first term squared. So he's going to be a squared. And then the sign is going to be the opposite of the sign you started. So if you have a difference of cubes, this is going to be positive. The second term is going to be the product of the two. We ignore the sign in the middle. The product of the two is going to be AB. And then the last term is always positive, and it's the second term squared. So that's the pattern. You got to remember the same sign goes here, and the opposite sign is in the second set of parentheses, and this is always positive. And that's going to be the pattern. The same pattern holds for the sum of cubes. So unlike perfect squares, we can factor the sum of cubes. It's going to be a plus b and then a squared minus ab plus b squared. Take a look. It's the same rule. Same sign, opposite sign, always positive. So I'm going to end this by doing one example, and then we'll continue in class to work through these. It might take 1 day, it might take 2 days. We'll see how it goes. This is a difference of cubes, and if I want to think about it, the cube root, I might put a little a down here. The cube root of x cubed is x, and the cube root of 8 is going to be 2. So those are the two things I'm going to put in my parentheses. My binomial is now x minus 2, same sign as the original, times the first term squared, the opposite sign, the product of the two, always positive, the last term squared. You cannot factor the trinomial anymore, even though it looks like you might be able to. Your final answer is the binomial and the trinomial. So that is factoring the sum and difference of cubes. And we'll work on more of this in class.